Hey class, this video is on 3.2a, complex numbers and introduction to complex numbers. So, complex numbers are written in the form a plus bi, where a and b are real numbers and the bi is the imaginary part. Okay, so a and b are real numbers and the bi is the imaginary part. I have a little kind of lame video I found for YouTube. If you want to watch that, you can look it up. But anyway, so where do the imaginary numbers fit in? Well, the real numbers include all the numbers you've known so far. They are the integers, fractions, whole numbers, irrational numbers. All of those numbers are our real numbers. Remember, we say x is an element of the real numbers. It includes all of those values. Now, the imaginary numbers are part of a complex number system. Over here, imaginary numbers are like 2 plus 3i, 5 minus 5i. Pure imaginary numbers are ones that just have the I part, like negative 4i. Imaginary numbers are used a lot in electricity. That's probably the number one place you might see imaginary numbers, like an electrical circuit or an electrical board. So anything that deals with electricity involves the use of negative numbers. But or the imaginary numbers? What defines an imaginary number? Remember when we used to say the square root of negative 4 and then you would say no solution? Well, actually, the square root of a negative number is an imaginary number. So we kept running into the square root of negatives and we needed a way to define them. So we made up the imaginary unit. And so the imaginary unit is defined, I is what we use to dictate it. And the definition of I, imaginary I, is the square root of negative 1, which means that I squared equals negative 1. So if you squared both, I squared equals negative 1, square root of negative 1 equals I. The imaginary unit can be used to find the square root of any imaginary number. For example, since you know that the square root of 16 is 4, the square root of negative 16 is 4i. The square root of negative 3 is irrational. It's just the square root of 3. It's a decimal. So we would say that the square root of negative 3 is just I square roots of 3. It's an imaginary square roots of 3. And really this comes down to, because you can break out 16, negative 16 is negative 1 times 16. And then the square root of negative 1 times the square root of 16 is square root of 16 is 4, and the square root of negative 1 is I, and I times 4 is 4i. So that's where that kind of breakdown is. Square root of negative 20, do you remember breaking these down? Factor tree. I know my former Algebra 1 students should remember this. You had to break out of jail is how I taught it. So 2 times 10, 2 times 5, you can grab a pair of 2's there. Or you can think of it like this. You could write negative 20 as negative 1 times 4 times 5. So the square root of negative 1 is I, the square root of 4 is 2, and the square root of 5 is irrational. So rewriting that, you always write the number first, then the I, then the square root. So the square root of negative 20 would be 2i square roots of 5. So breaking it down, I can take out a group of 2, the 5 stays in, and then the negative comes out as the imaginary I. So the imaginary unit can be used to find the square root of those imaginary numbers now, what we didn't think existed before. So remember we had the real part and the imaginary part. It was a plus bi. A is the real part and bi is the imaginary part. So here 2 is the real part and 4i is the imaginary part. 1/2, this is just a real number. So there is no imaginary part there. Here, negative 5 is the real part, and 2i is the imaginary. And 6i, this is a pure imaginary number, so there's no real part to that number, it's just an imaginary number. So now we can solve. Do you guys remember solving by square roots? You follow the, isolate the variable using your inverse operations and solve. So if x squared equals 64, just like addition and subtraction go together, and the opposite of a multiplication is addition, the opposite of squaring something is taking the square root. So if you wanted to get x by itself, you take the square root, which means you take the square root of this side. So the square root of x squared is x equals, and then you have the square root of 64 is 8, so the square root of negative 64 is 8i. And it's actually positive and negative 8i, because 8i squared would be negative 64, and negative 8i squared would be negative 64. So you have two answers, 8i and negative 8i. Just like 4 squared is 16, and negative 4 squared is 16. So if x squared equals 16, x can either be 4 or negative 4. Because we're solving for the variable has two options. If I just have an expression that says, what's the square root of 16? You say 4. But if I say x squared equals 16, then x can either be 4 or negative 4, because both of those values make that equation true. So that's the difference between finding the value of an expression and an equation. For the second part of example 2, you have to isolate the x squared. So you have to start by subtracting 26 from both sides. And you're starting with a negative 10 and you're subtracting. So really you're adding those together and you're going to get negative 36. And then get x squared by itself again by dividing by 2. And I'm going to get x squared equals negative 18. Then isolate the x by get rid of the square by square rooting both sides, and you're going to get x equals, now the square root of 18, you can either think of that as 18 is the square root of negative 9 times the square root of 2, so the square root of negative 9 is 3i, and then the square root of 2. Or if you've learned the factor tree method, that's 9 and 2, 3 and 3. So you can take out a group of 3 and the 2 is left in there. And then you also get the negative answer. So it's actually plus and minus 3i, or 3i square roots of 2 and negative 3i square roots of 2. So both answers there. Example 3, if I want you to write the expression as a complex number in standard form, I want you to write the complex number as a plus bi. And in adding or subtracting, we are looking to combine like terms, which means combine the real part and combine the imaginary part. So first, when you're adding, you don't really need the parentheses anymore because there's nothing here to distribute. It's like a 1, so it's really just negative 1 plus 2i plus 3 plus 3i. Combine the real parts, so negative 1 plus 3 gives me 2, and then 2i plus 3i is 5i. So combining it and writing it as a plus bi. In subtracting, you have to subtract both terms here, or we'd say you distribute a negative 1 through. So it's going to be 2 minus 3i minus 3, and then minus negative 7 will be plus 7i. So you have to distribute the negative when subtracting. Then combine your real parts. 2 minus 3 will be a negative 1. And then negative 3i plus 7i, negative 3 plus 7 is positive 4i. It's like 7 minus 3 essentially. I'm losing my voice, sorry. Hopefully you can still hear me okay. So here we have to subtract and then add. So it'll be 2i minus 3 minus I, then plus 2 plus negative 3i. So adding a parenthesis doesn't really change it unless there's a number out front. Then combining your real parts, so -3, +2 is going to be -1. And then we have 2i, -3. So just add from left to right. So these two give me are just an I, and then I minus 3 is -2i. So 2i minus I is -1i, and -1i, +1i, and then 1i minus 3i is -2i. This is what I got there. Again, writing it in standard form, so a plus bi, but multiplying. So this means that I need to distribute this I inside here. So this will be negative. The negative I is kind of like a -1i. So -1 times 3 is -3, and the I tags along, just like when you multiply by x, kind of. And then -i plus I will be -I times I is I squared. Then remember the definition of I squared equals -1, since the square root of -1 equals I. So I'm going to have to replace this I squared with a -1. So now I'm going to have -3i minus -1, which really is -3i plus 1. And then I want to rewrite it so the real part comes first. So it will be 1 and then minus 3i as a final answer. So I want the real part to come first, and the -3i part to come second. So 2i times 4 will be 2i times 4 will be 8i, and then 2i times -i will be -2i squared. And then I'm going to replace the I squared with -1. That'll look like this. I'll have 8i minus 2 times -1. So I'm only substituting in I squared for -1. That's going to be 8i plus 2. And then rewriting that in standard form will be 2 plus 8i. So just rearranging it. And then the last one, I have -3 times 6 will be -18i. -3 times -5 is -15. I times I is I squared. I squared equals -1. So I'm going to plug -1 in for that I squared, which will turn this -15 into a +15. And then rewriting it will be 15, and then it's -18i, so it'll be -18i. And that is written in standard form now with the real part first and then the imaginary part second. Okay, I think that's it for day 1 in complex numbers. There's lots of things that you learned, so make sure you go back and review your notes and get your homework done. Thanks for watching.